Welcome to qnawire.
Okay, we've got an electrostatic potential map, which I will try to replicate here. And the question is, what possible chemical formula could this have? Well, for one, there's only there's three atoms here, right? 1, 2, 3. So we can pretty much eliminate anything that doesn't have three atoms, right? So that means our remaining possibilities are H2O, OCS, or SO2. And what we need to know is the structure of these molecules, right? So H2O, if you didn't know, looks like this. Lone pair here, lone pair there. Okay. In SO2, we'll skip to, looks like this. Okay. Right. And OCS looks very similar to SO2. Right. And what we're going to point out here then is what are the dipoles of these molecules, right? So for H2O, we know that oxygen is more electronegative than hydrogen, so the dipole points in like that. And the same is true here. Okay, so the net dipole, the sum of these dipoles, the left and right parts cancel out, right? And we get something like that, right? Well, for SO2, we've got, actually it points out something like this, and something like this, and the whole thing cancels, and in fact, this isn't even polar. There's no dipole, right? So we shouldn't expect any kind of polar electrostatic potential map difference. And when we look at SCO, we see the net dipole is slightly to the right because oxygen is more electronegative than sulfur, right? So what I'm saying here is that one of these matches this electrostatic potential map, right? Does this look kind of familiar? Yeah, it matches water. Water is the only molecule that could potentially have this electrostatic potential map, right? Because it matches the dipoles that we've drawn for water. And the remaining molecules either have, no net dipole or it's purely linear.